These are the practice problems for lesson 11, equations of all kinds of lines. This is problem number 1. And they ask you to graph this equation. So you're given this equation and describe the steps that you would take to graph that equation. And then how would you check to make sure that that graph is correct? So the first thing I would do is write the form of this equation as y equals mx plus b. And just remember that m is the slope and b is where it crosses the y-axis, known as the y-intercept. So in this case, the slope is -4. And where it crosses the y-axis, what I want to do to be able to see that clearly is I'm going to change this to addition. So I'm going to use the inverse operation of addition and the additive inverse of a positive 1, which is -1. So I'm going to change that to addition, and it shows me that the y-intercept is -1. So I know it crosses the y-axis at -1, so that's 0 along the x-axis, -1 on the y-axis, and it has a slope of -4. So I can use that to find two other points using that slope and going in one direction and then going in the opposite direction. And also I can get two other points. First of all, I can check the y-intercept. If I make x equal to 0 and I put that into the equation, a -4 times 0 is 0. And that means that y is equal to -1. So this is the y-intercept. It's 0 on the x-axis, so it's still at the origin, but then the y-coordinate is -1, so it goes right here. So I would place a point right there. So that's the y-intercept. And the x-intercept, we really don't talk about the x-intercept much, but if you make y 0, then 0 equals a -4x plus 1. That's going to tell you what the x-intercept is. And so this is a -4x, and you can move it over to the left side by adding -4x. So 4x, 4 times some number equals -1, which means that 1/4 of that number is equal to x. So 4 times some number equals -1. X is equal to 1/4 of -1. Well, 1/4 of -1 is a -1/4. And so this point is a -1/4, and then it's 0. This is where it crosses the x-axis. Really don't use that much, and you don't really need to use it in this case, but it's a good exercise anyway to just check, see where it is, make sure it falls on the line. So then I would go to this point right here and use the slope. The slope is -4. So if I move 4 units along the y-axis, 1, 2, 3, 4, and that's -1 units along the x-axis. So that's 4 over -1, which puts me right there. So that's a -1, 3. So -1, 3 is that point. Or I can go from this point and I can move in the negative direction along the vertical axis. So that's 1, 2, 3, 4, and a positive direction along the horizontal axis. So this is a -4 over 1. So the slope is still -4. Whether you go this way, -4 over a positive 1, or you go this way, a positive 4 over -1. Slope is still -4, and this point down here is 1 along the x-axis and -5. So this is 1, -5. So then you want to use both of these points. You use both of these points to check to make sure that this graph is correct by fitting it and putting it into the equation and making sure that you get the correct value out for y. So I'm going to replace x with -1, and I'm going to also replace x with 1. I'm going to do these in parallel. So on the left side, it's y equals -4 times -1 plus -1. And out of this equation, I should get y equals 3. And this one, y equals a -4 times a positive 1 plus a -1. And so out of this equation, I should get y equals -5. So -1 here and 1 here. So you work through that. On this side, it's +4. So the opposite of 4 times a -1 is a +4. So 4 times -1 is -4, and the opposite of that is +4 plus a -1. Well, 4 plus a -1 is +3. So you do get a +3 out. And on the right side, the opposite, actually -4 times 1 is -4, plus a -1. So -4 plus -1 is -5. And so you do get an answer of -5. So for both of these points, they do check in the equation that you replace x with the x value, and you get the y value, the y coordinate of each point back after you do the calculation. There is another way to figure out the equation. This is what we used to do. A little bit harder, but it's useful to review it, because at times you're going to want to figure out the equation in this way, and that is to use a single point and the slope. So now you're not using the y-intercept, you're just using some other point on the line, and you're figuring out what's the vertical change, what's the distance along the vertical axis by subtracting y minus a -5 in this case, and what's the change along the x-axis by subtracting, by doing the calculation of x minus 1. So the vertical change is y minus -5, y minus -5, and x minus 1, x minus 1. So that ratio is equal to the slope. That's how far it's changing in the vertical direction compared to how far it's changing in the horizontal direction. It's changing a -4 times each unit that it moves in the horizontal direction. So it's changing a -4 times in the vertical direction for each unit that it moves in the horizontal direction. And so what this means is that y minus a -5 is a -4 times the change in the x direction. So it's a -4 times this amount. So now you can rewrite this as y plus 5. So I'm going to use the inverse operation of addition and the additive inverse of a -5 as a positive 5. So y plus 5 divided by x minus 1 equals -4. And so now this y plus 5 is a -4 times x minus 1. So I can write that. Y plus 5 is a -4 times x minus 1. Well, if I have a -4 x minus 1s, what I want to do is change this to addition. It's just easier to work with. So use the inverse operation, and the additive inverse of a positive 1 is -1. So changing subtraction to addition and using the additive inverse. And so now if I have a -4 times x plus a -1, that means I have a -4 x's. And a -4 times a -1 is the opposite. So -1 times some number is the opposite of that number. So -1 is times -4 is the opposite of -4, which is +4. So then move over here. So remember, if I added 5, so what I'm doing now is I'm sliding the slope triangle starting from here. I'm going down to here and over to here to create the slope triangle. So I slid it up 5 units to this horizontal axis, and I slid this point over 1 unit to the origin. So this is adding 5, and this is subtracting 1. So this is where you're subtracting -5 is the same as adding 5. So nice review of that, and you're subtracting 1. Well, if I added that 5, I then have to take that 5 away to get back down to here. So y is equal to -4x plus a +4 minus 5. I want to change that to addition because it's easier to work with. So that's adding a -5. So the inverse operation and using the additive inverse. So instead of subtraction, you can change it to addition and add the additive inverse. And so now you combine these. +4 plus a -5 is -1. So y equals a -4x plus -1, and that is the same equation as we got up here. Now this is a lot harder, and it seems like a lot harder, and it's a lot harder. But there are times where you're only going to be given another point and the slope. You're not going to know where it crosses the y-axis, so you're not going to know the y-intercept. So you're going to have to use this method to figure out the equation. And so it's a good review. This is problem number 2. You're given information for 4 lines and 4 equations. You're asked to write the equation for each of these lines that are defined by the slope and its y-intercept. So what I would do in the first case, in the beginning, is to write this equation, y equals mx plus b. And remember that m is the slope and b is the y-intercept. This is called the slope-intercept form of the equation. So there's the slope and the y-intercept. So you might make a note of that, the slope-intercept form of the equation. So if the slope is 0, so replace m with 0, the y-intercept is 5. Replace b with 5. Well, 0 times x, 0 times any number is 0. So this is going to go away, and you're going to be left with y equals positive 5. And we're going to graph that equation in a moment. The second one, the slope is 2, so replace m with 2, and the y-intercept is negative 1. Third one, the slope is negative 2, the y-intercept is positive 1. And the last one, the slope is negative 1 over 2, and that's the same as negative 1/2, so you can write it this way if you want. And the y-intercept is negative 1. So graphing each of those equations, the first one says y is equal to positive 5. So remember, that's going to be a horizontal line that's parallel with the horizontal axis, or the x-axis, because you can move anywhere along the x-axis, but the y-coordinate is always going to be a positive 5. So wherever you move, you're going to end up, the second move, the y-coordinate, is always going to end up being at this, on this line, at a positive 5. So you're going to create a line that is parallel to the y, or to the x-axis, or the horizontal axis. So that is y equals positive 5. Remember, when you have y equals any value, it's going to be a horizontal line equal to that value. That's going to be the y-coordinate. The next one, y is equal to 2x plus negative 1. So the slope is 2. The y-intercept is negative 1. So go to negative 1 and use a slope of 2 to identify other points on the line. So that means the slope of 2 means it's 2 units in the positive direction over 1 unit in the 2 units in the vertical direction and 1 unit in the horizontal direction. So that's 2 over 1. And then again, 2 over 1, or you can go 2 units along the y-axis in the negative direction, so that would be negative 2 over negative 1, a negative 1 unit in the horizontal direction. That is also a slope of positive 2. So it's negative 2 over negative 1. So you can start up here, negative 2 over negative 1, negative 2 over negative 1, negative 2 over negative 1, negative 2 over negative 1. Those are all a slope of positive 2. You can go in the reverse direction, positive 2 over positive 1, positive 2, positive 1, positive 2, positive 1, positive 2, positive 1. So this is a graph of this equation. The next one, the y-intercept is a positive 1 now, so they're using the inverse of negative 1, and the slope is negative 2, so they're using the inverse of positive 2. So it's the inverse of the slope, and it's the inverse of the y-intercept. So go to positive 1, so y is equal to positive 1, and then use a negative 2, a slope of negative 2. Well, that's 2, a positive 2 over a negative 1. Or you can go in the other direction, it's a negative 2 over positive 1. Both of those are a slope of negative 2. So negative 2 over positive 1, negative 2 over a positive 1, or a positive 2 over negative 1, positive 2 over negative 1. All of these have a slope of negative 2, positive 2 over negative 1, positive 2 in the y direction over negative 1 in the x direction. Notice that you get this x drawn, and you can try this with any equation. You're going to get an x that, I believe you always get the same pattern where you get an x that crosses, that intersects on the x-axis. So write another equation, y equals some value times x plus some y-intercept. Change the signs, write a second equation, change the signs, graph them, and you should get the same pattern of x, although it should move to the left or to the right, depending on what you do, along the x-axis. So you might try that, see if that's the pattern you get. And the last equation, the y-intercept is negative 1, so you go to y equals -1, and now it has a slope of -1/2. So that's 1 unit along the vertical axis, but a -2 units along the x-axis. So 1, -2, 1 over -2. Or you can go in the other direction. It's a -1 over +2, which is how they wrote it up here. -1 over +2, -1 over +2, -1 over +2. Remember, it's always the change in the vertical direction, -1, over the change in the horizontal direction, +2, and again going the other direction, a +1 over -2, +1 over -2. So a +1 over a -2, still a slope of -1/2. This is problem number 3, and this is practice writing equations for horizontal lines, the red and the blue line, and vertical lines, the green and the yellow line. So the red line, to write that equation, what I would do is look at the x-axis or the horizontal axis and just think about what's going on. You can move anywhere along this x-axis, so the x can be any value, but y has to be +4. So wherever I move, I'm going to end up moving along the y-axis 4 units. So this is an equation of y equals +4. So when y equals some value, you're going to get a horizontal line. Second example, again, I can move anywhere along this x-axis, but y has to equal -2. So if I start here at the origin and I go out to here, I go anywhere, I stop here, the y coordinate has to be -2. So I have to end up on this blue line. So again, y equals some value, that line is going to be a horizontal line because y has to be fixed. Y is fixed at -2. Up here, y is fixed at +4. For vertical lines, it's the opposite thinking. So now you can move anywhere along the y-axis, up and down, but you're going to start always at x equals -1. So you're going to go here to x equals -1, and now you can move anywhere along the y-axis to get the y coordinate. So this is going to be a vertical line that, of course, is parallel with the vertical axis or the y-axis. And the last example, same idea, x equals +6. So you're going to start out at 0, 0, and you're going to go to +6. But now you can go anywhere along the y-axis to graph the y coordinate. So this is going to be x equals +6, but y can be anything. So it starts out at x equals 6, and you go to 6, 0, but then the y coordinate can be anything. So you're going to get a vertical line that is parallel, once again, with the y-axis. So if you have x equals some value, you're going to get a vertical line. So x equals +6, x equals -1. You get a vertical line. If you have y equals some value, you will get a horizontal line because the other coordinate can be anything. So x can be anything, and in this case, these two cases, y can be anything. So you get a vertical line, y can be anything. You get a horizontal line, x can be anything. So you just have to carefully think through those. This is problem number 4. You are asked to write 4 equations. So in A, there's an equation, write an equation, write an equation, and then you're going to go back and rewrite these 2 equations with different information. And so you're going to write an equation about the total thickness of a book. And that book has a front cover and a back cover. And each of those covers for A and B have a thickness of 1/4 of an inch. And so you just have to kind of fight through the problem. Begin with what you know and slowly work through it. And what you know is that to write an equation, you have to identify what the 2 properties are. So what are the 2 properties in A here? Well, y is going to be the total width of the book. It says the width of the book y if it has x hundreds of pages. So one property is the width of the book. The other property is the number of hundreds of pages. You have 100 pages, you have 200 pages, 300 pages. So how many hundreds of pages do you have? And that is a proportional relationship. So y is equal to x, and that's connected by the ratio of the thickness per 100 pages. So y per x, or the thickness per 100 pages. But then what's added to these kinds of problems is you have to go back and add the thickness of the covers. So it's not a proportional relationship in the total thickness, but just the hundreds of pages are proportional to the thickness of the book. But then you have to go back and add the covers. So the proportional part of this is y equals mx, where m is the number, the thickness per 100, per hundreds of pages, at 1/4 of an inch per hundreds of pages. So how many of those do you have, plus the front and the back covers? Well, the front cover plus the back cover is equal to 1/2 of an inch. Remember, you have 1/4 of an inch for the front cover, 1/4 of an inch for the back cover, so 2 times 1/4 is equal to 2/4, which simplifies to 1/2 of an inch. So now this is the equation to use. So m is the relationship between the thickness due to the hundreds of pages, but then you have to go back and add the thickness due to the covers. So it's 1/4 for A, it's 1/4 of an inch per 100 pages. So 1/4 of an inch per 100 pages. So 1/4 of an inch per 100 pages plus the front and back covers. So y is equal to 1/4 of an inch per 100 pages. So if I have 100 pages, that's going to be 1/4 of an inch. If I have 100 pages, or 200 pages, that's going to be 2 times 1/4, 3 times 1/4, 4 times 1/4. But every single time, you have to go back and add the thickness of the covers. Added together, front and back cover equal 1/2 of an inch. So you have to go back and add that. If the thickness of the pages is 2/5 of an inch per 100 pages, this one was 1/4 of an inch per 100 pages. But these pages are a tiny bit thicker. This is 4/10 of an inch. This is 25/100 of an inch. So this is a little bit thicker, actually quite a bit thicker. So 2/4 of an inch per 100 pages. So depending on the number of hundreds of pages you have, you multiply that times 2/5. But then remember, you have to go back and add the thickness of the cover. So you have to add this 1/2 of an inch. Now, what if they change the thickness of the covers? Instead of the front and back covers being 1/4 of an inch, they're going to change it to 1/3 of an inch. But remember, you have 2 covers. You have a front and a back. So that means a total thickness of 2/3 of an inch gets added instead of 1/2 of an inch. It was 1/2 of an inch up here. It's going to be 2/3 of an inch down here. So now you go back to A. The thickness due to the pages is still 1/4 of an inch per 100 pages. So that's 1/4 of an inch per 100 pages. But now the thickness is 2/3 of an inch that has to get added. And for B, the thickness of just due to the pages is 2/5 of an inch per 100 pages. So 2/5 of an inch per 100 pages, but then you have to add the thickness of the covers, which is 2/3 of an inch. So these are 1/4 of an inch per 100 plus 1/2 inch, 2/5 of an inch per 100 pages plus 1/2 of an inch, 1/4 per 100 pages plus 2/3 of an inch, and 2/5 of an inch per 100 pages plus 2/3 of an inch.